When your system starts to struggle under load, you have two fundamental levers to pull: make each machine bigger or add more machines. This video explains both strategies, shows why different tiers of a layered system often need different answers, and gives you a practical framework for choosing between them. As traffic grows, each tier in your architecture hits its own ceiling. The presentation tier might run out of threads, the business logic tier might saturate CPU, the database might exhaust memory. The pressure is the same in every case, more demand than current capacity, but the right response depends on what kind of work that tier actually does. That is why the two approaches are so easy to confuse. They solve the same symptom through very different structures. Imagine a busy restaurant kitchen. If orders pile up, you could replace your one chef with a world-class speed demon, that is vertical scaling. Or you could open more prep stations and staff each one, that is horizontal scaling. The second approach can handle far more orders, but now you need someone at the front routing each ticket to a free station. That router is the load balancer in a real system, and its presence is what makes horizontal scaling structurally different. Here is the structural difference made visible. On the vertical path, the client talks to one machine that has been upgraded to handle more load. There is only ever one box, and it just keeps growing. On the horizontal path, a load balancer sits in front of two or more identical servers and spreads incoming requests across them. Adding capacity means adding another box behind the load balancer, not replacing the existing one. The shape of the system changes fundamentally. Trace a single request through a scale 3-tier system. The browser contacts the load balancer, which forwards the request to whichever web server has capacity. That is the presentation tier, and it is stateless, so any instance can answer. That server calls one of several application servers handling business logic, also stateless, also freely scalable horizontally. The application server then reaches the database, which is typically a single primary node scaled vertically. The response travels back up the same path. Notice that the data tier breaks the purely horizontal story. It often scales differently from the tiers above it. Let us put the two approaches head to head. Vertical scaling is operationally simple and fits stateful systems well, but every machine has a physical ceiling, and resizing often requires downtime. Horizontal scaling removes the ceiling and improves fault tolerance, but it demands that your tier be stateless. If each request can land on any server, no server can hold local state like an in-memory session. It also introduces real infrastructure overhead, load balancers, health checks, and sometimes service discovery. The right choice is not universal, it depends on the tier. The key insight is that tiers have different natures, so they earn different strategies. Presentation and business logic tiers are typically stateless. A request carries everything the server needs, so any instance can serve it, which makes horizontal scaling natural and safe. Databases carry state internally, which makes distribution hard. Vertical scaling buys time, and read replicas handle read-heavy load before you commit to the complexity of horizontal sharding. For short, predictable spikes, vertical scaling is faster to apply. For sustained growth or high availability requirements, horizontal is the more durable answer. To sum up, vertical scaling is the simpler move. One machine gets more power, but it has a hard ceiling and often requires downtime. Horizontal scaling removes the ceiling and improves resilience, but it requires stateless design and added infrastructure. The most important takeaway is that these are not system-wide choices. Your presentation tier, your business logic tier, and your data tier may each use a different strategy, and recognizing that is the mark of mature architectural thinking.